Welcome to another coding tutorial, and in today's video, we're going to be making a collage using a simple trick. The simple trick that I talk about is to use the built-in function called get, which allows us to get the color information of a specific pixel on the canvas. And we have used this technique before in many tutorials, including the ASCII text, images, and videos, where we use the get function to get the brightness value of a specific pixel. But in this tutorial, we're not going to get the color information of a specific pixel, but actually of a specific region or a portion of the canvas. So let's see how we can do that. But before we get there, first I'm going to upload an image onto the canvas, and you can do that by clicking this arrow here, then click the plus sign and then upload file. And this is where you're going to drag and drop your image file in there. Once your file is uploaded, what you want to do is you want to write a function called preload. This function is going to allow you to preload an image before you run the program. And you also want to create a variable. Let's call it img. And we're going to set img to another function called load image. Then inside here, as an argument, we're going to put in where the file is. Ooh, I guess my file was not uploaded. All right, and then my file is called cnx.jpg, and make sure that you put it in a quotation mark. So cnx.jpg, and then let's click run to make sure everything is loaded properly. Yep, and then it is. So now what you want to do is you want to come to the draw loop here, and then we're going to display the image by using the function called image. We're going to provide a total of 3 arguments. The first one is the name of the image file, and then the second and the third are going to be the x and y coordinates of the top left corner of where you want to display the image. Then let's click run. And as you can see here, it's just a picture of a cloud. But actually, this is not my entire image. It is because the file size is much bigger. And to resize the file, what we can do is we can use the method called resize. First, you need to put in the name of your image file, img, and then dot, and then resize. And then we're going to provide the width and the height as the 2 arguments. So you can do, for example, 200 by 200. And as you can see here, we get an image of the size 200 by 200. You can't really tell from this image, but actually this is not resizing properly because it is being kind of squished. So what I can do is I can actually just provide the first argument as the width that I want, and then the second argument I'm going to put in 0. And by doing that, actually I'm going to do 400 for now. And by doing that, the height is resized proportionate to whatever the width is. And now what I want to do actually is to put this before the create canvas function, and then I'm going to change it to 500. And then the reason I want to do this is so that I can change the width and the height of my canvas to be the same size of my image. So I can just do img.width and then img.height. Next, we're going to see how we can use the built-in get function to get the pixel information of a region of an image. So what we want to do is, how about we set a variable called region, and then set it equals to img, which is this image here, dot get. And usually when we want to get the color information of a specific pixel, we can just provide 2 arguments, the x and y coordinates of that pixel. But to get a region, you want to provide a total of 4 arguments. The first 2 are going to be the x and y coordinates of the top left corner of the region, and then the third and the fourth are going to be the width and the height. So how about we do 100 by 100, and let's do a size of 200 by 150. And then instead of displaying img here, we're going to display region, but we're going to display it still at 0,0 here. All right, and how about we do image of img 0,0 again. And as you can kind of see here, this image here, the portion here, is being taken from somewhere around here and being placed here, right? So basically I just randomly crop an image out of this big image and then place it at the top left corner here. But to make the collage that you saw at the beginning, we're not going to randomly pick a region of this big image. We're going to do it in two ways. The first way is that we're going to cut up this image into equal vertical strips based on the number of columns that we want. And then the second way is we're going to cut it up into a specific number of columns and rows, and then we're going to get a grid that have the same exact size. All right, so let's go with the first example. What we want to do is that we want to cut this image into equal vertical strips. To do that, first, I'm going to declare a few variables. The first one is, how about columns? And we're going to set the columns to, how about 10? And then we're going to set another variable, let's call it strip width. And strip width is going to be based on the number of columns here, right? So inside setup, you also want to calculate that. So strip width is going to be the width divided by the canvas width divided by columns. I'm going to declare an array, and let's call it strips. And this array basically is going to store the region information of each of these strips. So I'm going to use a for loop that goes from I equals to 0 to I less than columns, I plus plus, and then inside strips, we're going to do the same thing as here. So img.get, instead of hard coding the numbers here, what we want is actually I times strip width, right? And then for y, it's going to go from 0 to, so it's going to be these locations here, right? For the x location, y will be 0, and then it's going to be the width of strip width, and then the height will be strip height, which is the height of the canvas. So let's just put height. After that, what we can do is we can just display the image. I can just put everything inside setup so that it can only be called once, because we're not doing any type of animation here, but we can also do another way by using a function called no loop. And no loop basically is allowing us to call the draw function only once. And I'm just doing this to be efficient because you don't need to recall the same thing over and over again. All right, so now inside the draw function, what we want to do is I'm going to comment out this one, and then we can delete the region. Then now we're gonna need the same for loop. So for I equals to 0, I less than columns, I plus plus, then we want to display the strips, right? So strips of I, and then at what location, it's going to be the same thing as here. Let's click run. And it just looks like if we were to just write this function here, right? Because we have not shuffled around the order at which we put in this region information inside the strips array. So we can do that quite easily using the built-in function called shuffle. And how we can do that is, how about we start by creating a variable called shuffled strips, and then set it equals to a function called shuffle. And basically we just need to put in an array that we want to shuffle, and it's just going to shuffle the stuff inside that array. And then that array is strips, right? And then instead of strips of I, this shuffle strips is also an array. So now it's going to be shuffled strips, same location, and let's click run. Ta-da! And you can just change the size here. How about 50? That's pretty cool. So you can just play around with this already, making vertical strips, making horizontal strips, and maybe just take a portion of this. You know, just play around. A lot that you can do with this. The next example that I'm going to show you is, instead of just making these vertical strips, how about we make a grid of random regions? So let's go to a new sketch. Alright, so in this one, I have already prepped a sketch where I uploaded the image and then called the function preload, loaded the image, resized the image, and also called the image to draw on the canvas. In this example, instead of getting the region that is the size of the height of the canvas, we're going to actually declare both number of columns and rows, and also strip width and strip height. So let's start with that. First, we're going to declare a few variables. Let's do calls, set it to 10, rows, set it to 10, and then strip width and strip height. Inside setup here, let's start with no loop. And then we're going to calculate strip width, which is going to be width divided by columns, and then strip height will be height divided by rows, right? And then next, we're going to create an array called strips. This is similar to the previous one, but instead of being a 1D array, it's going to be a 2D array because we need to store information of a grid of regions, right? So now inside setup here, we're going to use a nested for loop that goes from I equals to 0 to I less than columns, I plus plus, and then j equals to 0 to j less than rows, and then j plus plus. So first we need to create a 2D array out of this. So inside this outer loop here, we need to set strips of I to be equals to 1D empty arrays, and then inside here, strips of I and j will be set equals to img.get, right? And then now instead of just I times strip width, now the second argument will be j times strip height. And actually, how about I set this as x and y? So let's do x equals to I times strip width, and then y to be equals to j times strip height. All right, so this is x and y, and then for the width and the height, it will still be strip width and strip height, right? Now inside draw, we're going to copy and paste this. We can comment this out, and then instead of all of this, we don't need to, we can just delete this line of code, right? We still want x and y here, but we're going to use the image function to display strips. So let's do strips. Actually, how about we call it grid? Grid width.
A few moments later.
All right, and then we're going to do grid at what location x and y. Click run. Oh, I and j. Ta-da! Okay, so this is not what we want, but I want you to notice one thing first. So as you can see here, there is this like strip, like a small strip that goes across each of these horizontal strip. What is this? So how about we print out grid width and then grid height. And as you can see here, it's 50 and 37.5. It leaves a little bit of, this is like the 0.5 decimal here. So one thing that you can do to fix this, but it's not a really good fix, is that instead of having this decimal point, how about you use a function called floor, which basically turns a decimal value into the closest integer. So if you do this, you can see that the lines are gone, but you can also see that now there is a small strip, a bigger strip at the bottom. But another thing that you can do to fix it is that what if we just make sure that the image that we use or the values that we will put as the columns and rows here, when divided, the grid width and grid height are integer values. So instead, I'm going to resize it to, how about 600? And then now there's no issue. So you can play around with the variables that you choose to do and then just fix it the way that you want. And maybe those tiny strips that you see might be the aesthetics that you want. Who knows? All right, so what we want to do next is that we want to shuffle this around, right? So how about we just do let shuffled grid and then set shuffle to grid. And then now inside here, we just do shuffle grid. But you can see here that the things that are being shuffled are only the vertical strips, which is this I values here. Using the shuffle and providing a 2D array inside here does not actually shuffle everything inside. So not the elements inside the 1D array inside the 2D array. So to be able to see that, let's go to a blank sketch. How about I create a 2D array with 3 1D arrays. So let's do 1, 2, 3, 4, 5, and 6. And then now I'm going to print shuffle of ARR, which is a 2D array. And as you might have expected, the 1D arrays inside here are being shuffled. As you can see, the orders are not the same, but the elements inside are still the same, in the same order. So if I were to do shuffle of ARR of, let's do 0. So we want to shuffle this 1D array, click run, and you can see here, it's being shuffled, right? It's either 2, 1 or 1, 2. So what we're gonna do is that right now, this shuffled grid basically shuffled the 1D arrays, but now we want to shuffle the elements inside, and that elements are the stuff inside the rows here. So we're going to do shuffled elements, and then we set shuffled to shuffled grid. And then in here, we need to do shuffled elements. Let's try that. Ta-da! It works. And now you get a pretty cool collage. So before I end here, I just want to add the margins. And I can do that quickly by first, how about we declare margin, set it to 100, and then we just need to change up the calculation here a little bit and then actually declare 2 more variables. Let's do x0 and y0. And then x0 will be equals to margin, and y0 will also be equals to margin. Basically, this is going to be the start of where this x and y is going to be. So instead of I times grid width and j times grid height, it's going to be x0 plus this, and then y0 plus this. Same thing here, x0 plus, and then y0 plus. And don't forget, now the grid width and grid height is not the entire width and the entire height anymore. It's going to be width minus margin times 2, and then height minus margin times 2. All right, and then how about I also uncomment this image. That looks pretty cool. It looks like you're looking through like a cool glass or something. And these are 2 very simple examples where you can just use the get function to get pixel information of a specific region. But I think you can do a lot to manipulate the image in the way that you want. So give this one a try.